Hello, third graders. This is Miss Glassy, and today I'll be teaching you more about finding the area of rectilinear figures. You'll need a pencil and several pieces of paper for today's lesson. If you do not have a pencil and paper in front of you, please pause the video and get the materials you'll need. Our target for today is, I will be able to decompose a rectilinear figure to determine the total area. Let's start by reviewing some vocabulary. Our first vocabulary word is area. Area is the total amount of space an object covers. It's the number of square units inside of a shape. You can see that this rectangle covers a certain amount of space. In fact, you can see all of the square units inside of the rectangle that the rectangle is covering. If you were to count all of the square units inside of the rectangle, you would see that the rectangle covers 18 squares. That means that the total area of this rectangle is 18 square units. Oftentimes, when we want to find the area or space covered by an object, we cannot see the square units inside of the shape. When we want to find the area of a rectangle, we can find the area of a rectangle by multiplying the length of the rectangle times the width of the rectangle. Length times width equals the area of a rectangle. Look at this teal rectangle here. You can see that this rectangle is 5 feet wide and 3 feet long. 5 times 3 equals 15. So the total area or amount of space covered by this rectangle is 15 square feet. Remember, area is always measured in square units. Let's take a look at a rectangle and remember what we know about rectangles. Rectangles are shapes with 4 sides. They have 4 right angles, and the opposite sides of a rectangle are parallel. The opposite sides of a rectangle are also the same length. The top side and bottom side of the rectangle are opposite of each other. So we know that they are parallel and also the same length. The left and right side of the rectangle are also opposite of each other. That means that we know the left and right sides are parallel and also the same length. If we wanted to find the area of this rectangle, we could multiply the length of the rectangle times the width of the rectangle to find the total area or space covered. Yesterday, you began learning about finding the area of a rectilinear figure. Rectilinear figures are shapes with only right angles, and they can be decomposed or broken down into rectangles. We learned that when we want to find the area of a rectilinear figure, like the rectilinear figure you see here, we have to decompose the figure into rectangles and then add the areas of each of the rectangles together to find the total area of the entire shape. Let's take a look at this example I have here. You can see I've already decomposed this rectilinear figure. I've decomposed it into a larger 5 by 3 rectangle on the top and a smaller 2 by 3 rectangle on the bottom. To find the total area, I have to add the area of each of those 2 smaller rectangles together. So let's do that. Look at rectangle 1. The size of rectangle 1 is 5 by 3. Oh, pardon me. Look at rectangle 2. The size of rectangle 2 is a 2 by 3. If I want to find the total area, I have to add the 5 by 3 rectangle plus the 2 by 3 rectangle to equal the total area. A 5 by 3 rectangle has an area of 15 square feet because 5 times 3 equals 15. A 2 by 3 rectangle has an area of 6 feet because 2 times 3 equals 6. To find the total area of the entire rectilinear figure, I add 15 plus 6. 15 plus 6 equals 21. So the total area of the entire rectilinear figure is 21 square units. You also learned yesterday, third grade, that rectilinear figures can be decomposed in more than one way. We learned that as long as you're decomposing the rectilinear figure into rectangles and adding the area of all of the rectangles back together, it does not change the total area of the rectilinear figure. You can decompose rectilinear figures in multiple ways. Let's decompose this same rectilinear figure in another way. Here's that same rectilinear figure, but you can see here I've decomposed the figure differently. Now I have one rectangle that's a 3 by 3 and another rectangle that's a 2 by 6. Let's look at how we could represent this mathematically using equations to find the total area. What size is rectangle 1, the rectangle with blue writing? I agree, that rectangle is a 3 by 3. I know that if I want to find the area of the entire figure, I need to add that 3 by 3 rectangle to the other rectangle. What size is the second rectangle, the rectangle with green writing in it? Yes, rectangle 2 is a 2 by 6. So to find the total area of the entire rectilinear figure, I need to add rectangle 1, the 3 by 3 rectangle, plus rectangle 2, the 2 by 6 rectangle. What is the area of a 3 by 3 rectangle? What does 3 times 3 equal? 3 times 3 equals 9. So the area of that 3 by 3 rectangle, rectangle 1, is 9 square units. What is the area of a 2 by 6 rectangle? What does 2 times 6 equal? Yes, 2 times 6 equals 12. So the area of rectangle 2, the 2 by 6 rectangle, is 12 square units. To find the total area of the entire rectilinear figure, we need to add together 9 plus 12. What is 9 plus 12? Yes, 9 plus 12 equals 21. So the total area of the entire rectilinear figure is 21 square units. This is the same answer that we found when we decomposed the rectangle a different way. That's because it doesn't matter how you decompose the rectilinear figure, as long as you decompose it into rectangles. The total area of the entire figure stays the same. Let's take a look at another example. Now, third grade, it's going to be your turn to do the work with me. Let's look at this rectilinear figure. How could I decompose this rectilinear figure into smaller rectangles? Take a moment and see if you can find 2 ways we could decompose this rectilinear figure. Excellent. I'll bet you found 2 different ways. We're going to choose one of the ways and solve and find the area of this rectilinear figure. Let's decompose this rectilinear figure by splitting it horizontally, with a larger rectangle on the top and a smaller rectangle on the bottom. Excellent. Let's take a look, third grade, at rectangle 1. We'll call the top rectangle, rectangle 1. I'll outline it in blue so it's easy for us to see. Today, third grade, the rectilinear figures you're going to see will not show the square units inside of them, so we won't be able to count to double check our answer. We'll have to rely on our correct multiplication to make sure our answers are correct. What is the size of this rectangle, third grade? The blue rectangle, rectangle 1. Yes, this rectangle is an 8 by 4 rectangle. It's an 8 by 4 rectangle because it's 8 feet wide and 4 feet long. Today, third grade, instead of writing the size of the rectangles on the rectilinear figure, I'm going to represent my mathematical thinking using only equations. So, rectangle 1 is an 8 by 4 rectangle. I'd like you to write the mathematical equations on your paper while I write them on the screen. We know we need to add the area of that first rectangle to the area of the second rectangle to find the total area. Rectangle 2 is this smaller rectangle that I'll outline in green. What is the size of this smaller rectangle? You may have noticed that when we look at this rectangle, one of the sides says 4 feet and one of the sides says 8 feet. You'll have to think carefully about whether this is a 3 by 4 rectangle or a 3 by 8 rectangle. I'm sure you'll notice that the side that's 8 feet long goes the entire distance of the rectilinear figure. But the rectangle we're talking about is smaller. It only goes part of the distance. It only goes 4 of the feet up. So this rectangle is a 3 by 4 rectangle. I'll add that to my mathematical equation. I know that if I add the 8 by 4 rectangle plus the 4 by 3 rectangle, it will equal the total area of the entire rectilinear figure. Now, third grade, I need to think about what 8 times 4 is. If you need to pause the video and use a strategy or your for song to find the answer to 8 times 4, go ahead and do that. 8 times 4 equals 32. The area of rectangle 1 is 32 square units. I need to add that to the area of rectangle 3, the 4 by 3 rectangle. What does 4 times 3 equal? That's right, 4 times 3 is 12. So the area of rectangle 2 is 12. I need to add 32 square units plus 12 square units to find the total area. You already know, third grade, that we always do our best addition when we add vertically. So I'm going to write the problem vertically and carefully add. On your paper, carefully add 32 plus 12. 32 plus 12 equals 44. 44 equals the area. The total area of the entire rectilinear figure is 44 square feet. I know it's square feet because area is always measured in square units, and on this rectilinear figure, I can see that the unit is feet. Excellent job, third grade. Let's look at another example. Here's another rectilinear figure. We're going to decompose this into 2 rectangles so that we can find the area of the entire rectilinear figure. Can you think of 2 different ways we could decompose this rectilinear figure? I'll bet you found 2 different ways we could decompose this shape. Let's decompose this rectilinear figure by splitting it vertically, with a smaller rectangle on the left and a larger, longer rectangle on the right. We know we need to add the area of the first rectangle plus the area of the second rectangle to find the total area of the entire shape. Let's call this smaller rectangle, rectangle 1. I'll outline it in blue. On your paper, write down what size this rectangle is to start our mathematical equations. Yes, I respectfully agree. Rectangle 1 is a 3 by 4 rectangle. We know we need to add the area of that first 3 by 4 rectangle to the area of the second rectangle. What is the size of the second rectangle? I'll outline the second rectangle with green so it's easy to see. You might notice that the top and bottom sides have different lengths written on them. The top says 9 centimeters, but the bottom says 6 centimeters. So, is this rectangle really 9 centimeters long or 6 centimeters long? Let's use our mathematical reasoning to think about this. I can see that the side labeled 9 centimeters long goes the entire distance from one side of the rectilinear figure all the way to the other side of the rectilinear figure. But the rectangle I'm thinking about, rectangle 2, isn't the full length of the entire rectilinear figure. In fact, it only goes part of the way. This rectangle is actually 6 centimeters long, not 9, because we broke the 9 apart into this part of the rectangle and then the other rectangle. So, third grade, that means that this rectangle, rectangle 2, is a 6 by 3 rectangle. I know that I need to add those 2 together to find the total area. What is the area of a 3 by 4 rectangle? What does 3 times 4 equal? If you need to pause the video to give yourself time to use a strategy to find the answer, you may do that. 3 times 4 equals 12. So the area of that first rectangle is 12 square units. Rectangle 2, the green rectangle, is a 6 by 3. What is the area of a 6 by 3 rectangle? What does 6 times 3 equal? 6 times 3 equals 18. So the area of the second green rectangle is 18 square units. I know I need to add the area of rectangle 1 plus the area of rectangle 2 to equal the total area. Please make sure, third grade, you're writing the same mathematical representations on your paper that I'm writing on mine. This is how you will solve these problems. You already know, third grade, that to add 12 plus 18, we're going to write them vertically so we can do our best adding. Go ahead and write 12 plus 18 vertically and find the answer. 12 plus 18 equals 30. 30 is the area. The area of the entire rectilinear figure is 30 square centimeters. Very good, third grade. Now that you've solved quite a few rectilinear figure problems, I think you're ready to see a challenge problem. Let's take a look at this last problem, a challenge problem. When you look at this rectilinear figure, how could we decompose it into rectangles? You might notice that there's no way to decompose this into just 2 rectangles. In order to decompose this rectilinear figure into rectangles, we'll need to decompose it into at least 3 rectangles. Pause the video and see how many ways you can find to decompose this rectilinear figure into at least 3 rectangles. I'll bet that you found several ways we could decompose this rectilinear figure. Here's how I'm going to decompose this rectilinear figure. I'm going to decompose this rectilinear figure by first splitting it horizontally, making a small rectangle on the top. You can see that the rest of my shape is still not a rectangle, so I'll need to decompose it again to make another rectangle. In order to make a third rectangle, what I'm going to do now is I'm actually going to decompose it vertically, making a small rectangle on the side, a smaller rectangle on the top, and a larger rectangle down here. Now I have 3 rectangles that I can find the area of. You may have thought of other ways to decompose this figure into rectangles. Remember, there are multiple ways to decompose a rectilinear figure. Now, third grade, to solve this problem, I need to find the area of each of the rectangles I've created, and then add them all together. Let's start by figuring out what size each of these rectangles are. Let's call this top rectangle rectangle 1. I'll outline it in blue. What size is rectangle 1? You may write it on your paper. I respectfully agree. This is a 5 by 4 rectangle. I'm going to add rectangle 2 and rectangle 3 to that 5 by 4 rectangle to get the total area. We'll call this other small rectangle rectangle 2. I'll outline it in green so it's easy to see. What is the size of this second rectangle? I respectfully agree. This is a 3 by 4 rectangle. So I'll add rectangle 1, the 5 by 4 rectangle, plus rectangle 2, the 3 by 4 rectangle, plus rectangle 3. I'll make this rectangle outlined in purple so it's easy to see. What size is this third rectangle? You may write it on your paper. I respectfully agree. This third rectangle is a 6 by 5 rectangle. When I add the areas of all 3 of those rectangles, rectangle 1, rectangle 2, and rectangle 3, it's going to tell me the total area of the entire rectilinear figure. Now that I know what size each rectangle is, I can go back and find how many total square units each rectangle is, or the area of each rectangle. Rectangle 1 is a 5 by 4 rectangle. What does 5 times 4 equal? Yes, 5 times 4 is 20, so the area of rectangle 1 is 20 square units. What is the area of the 3 by 4 rectangle? What does 3 times 4 equal? Yes, 3 times 4 equals 12. So the area of the second rectangle is 12 square units. Now I need to add 20 plus 12 to the area of rectangle 3. Rectangle 3 is a 6 by 5 rectangle. What is 6 times 5? Yes, 6 times 5 equals 30. So the area of the third rectangle is 30 square units. If I add the areas of rectangle 1, rectangle 2, and rectangle 3 together, it will tell me the total area of the entire rectilinear figure. I know that to do my very best adding, I need to write each number vertically and add them together. Thankfully, I can add 3 numbers at once. Go ahead and add 20 plus 12 plus 30 on your paper vertically. 20 plus 12 plus 30 equals 52. 52 is the area. The total area of this entire rectilinear figure is 52 square inches. Excellent, third grade. Now that we've completed some practice problems together, I can tell that you are ready to complete your assignment.